So today we're going to talk about natural logs and common logs. A common log is a log with base 10. So remember how we talked about whenever you saw a logarithm and it didn't have a base written, that we could assume that it was 10. So it's just a log, the base 10. Okay? Now, we can use this to solve some equations by taking the common log of both sides. Remember how if you add something to one side, you got to add it to the other. We got to be fair in math. So we're going to write can be used to solve equations by, and we're going to use some quotations, taking the log of both sides. Okay, so let's start with some examples. So let's look at example 1. It says we need to solve. Now, in your head, you can't think of anything to raise 3 to the power of the 11 because, 3 to the first power is 3, 3 to the second power is 9, 3 to the third power is 27. So we know it's got to be somewhere between 9 and 27. But usually we can't figure that out. So let's do this. Let's take the log of both sides. So we're going to take log of 3 to the x power is equal to log of 11. Now, I didn't write the bases here because what we have is a base 10. We're using the common log. And that's what your calculator calculates for you. Whenever you type in a plain log, it does base 10. So now, we've got to use those same properties we've been talking about. We've got this x up here as an exponent. So we need to bring it to the front. We're going to use the power property. So we have x times log of 3 is equal to log of 11. Now, we can use the calculator to evaluate log of 3 and log of 11. These are just numbers. They're just not pretty numbers. So to get the x by itself, we've got this log of 3 multiplying it. So all we have to do is divide both sides by log of 3. They're going to cancel out here. So in your calculator, you need to type in log of 11 divided by log of 3. And we're going to round it to 3 decimal places. So you have 2.183. And then we just talk about how it would be between 2 and 3. Well, there's our answer, between 2 and 3. So, here we go. Okay, let's look at example B. Same thing here. We don't really know what's going on. So, let's take the log of both sides. Log of 5 to the 3y is equal to log of 8 to the power of y minus 1. So we're going to use that power property again. We're going to bring the exponents out to the front. So we have 3y times log of 5. And then we have, let's use some parentheses around everything. See, this time we've got an expression coming down as the exponent, so we definitely need to use some parentheses here. Log of 8. Okay, at this point, we can go ahead and use the calculator to evaluate some things. So, on the left-hand side, we can multiply 3 and log of 5. So if you go in your calculator and you type in 3 times log of 5, you're going to get 2.097. Now we still got our y over here, so we're going to write y. And that's going to be equal to, now over here, we're going to have to use the distributive property. So we got to find out what log of 8 is, and then we're going to distribute to the y and to the negative 1. So, log of 8 in the calculator is 0.903. So for the first one, y times log of 8, we have 0.903y. Then we have minus, and log of 8 times 1 is 0.903. Now, it looks just like any other equation. It just so happens that we don't have very pretty numbers. We've got some decimals in here. So we need to get our y's together. So I'm going to take 0.903y, and I'm going to subtract it from both sides. So I'm going minus 0.903y, and I also have to subtract it from here. And this is something you can type in the calculator. You can say 2.097 minus 0.903, and you end up with 1.194, and these are y's, remember? They canceled out here, and then you have negative 0.903. And last thing we need to do is divide both sides by 1.194. They cancel out here. And finally, you get y is negative 0.756. And there you have it. So now we need to talk about natural logarithms. Natural logarithms are log base e. Now it has its own notation. We use ln, which is actually kind of backwards for natural log. It's kind of like log natural. But you have a button for it on your calculator. It's right below your normal log button and right to the left of your number 4 button. So, and remember, e is just a naturally occurring number. It's called a transcendental number. Transcendental. It's a lot like pi. You know how pi represents the circumference ratio with the diameter? So, it's naturally occurring just like pi. It's a transcendental number. Okay, we also have these properties. If you have an e to the power of natural log, these kind of cancel out and you're left with the x. And if you take a natural log of e to the x would be what was left because you bring it into the front. And the natural log of e is just 1. Now, we're going to use these properties to solve equations. Okay? So, in order to use these, you got to do one thing. We have to isolate the e or the natural log. And then we can use those properties. Now, just like before when we took log of both sides, sometimes we're going to be able to take natural log of both sides, but also we can make both sides exponents of an e. And we'll see that in just a minute. Also, you need to remember, natural logs are logarithms. So we can use the power property, the quotient property, and the product property, just like we would for regular logarithms. So remember, the only difference is, instead of writing log base e, you write natural log. So let's look at some examples. Okay, so in order to do this, remember, previously we said that we have to get the e or the natural log isolated. So if you look here, we have e to the negative 2x. We want to get that by itself. So if we were treating this like any other expression, we would need to do some algebra here. We need to subtract 4 and then divide by 3 on both sides. So let's do that. So let's subtract 4 from both sides. And then we still have 3e to the negative 2x. The 4's would cancel and you're left with 6. Then, to get the e to the negative 2x isolated, we need to divide by that 3 that's in front of it. So we're going to divide both sides by 3. And you have e to negative 2x is equal to 2. Okay, now, here is where we need to use those properties. If you're left with an e, you're going to use natural log. So, since we have an e, just like before when we took logs of both sides, we're going to take the natural log of both sides. So we have natural log of e to negative 2x is equal to natural log of 2. Now, from the property that we just talked about, this is all that's going to be left on the left-hand side. So we have negative 2x is equal to natural log of 2. Now remember, your calculator will calculate what natural log of 2 is for you. So to get x by itself, the last thing we need to do is divide both sides by negative 2. So in your calculator, go in and type natural log of 2 divided by negative 2, and you get negative 0.347. Okay, moving on to example B. This time, if you notice, we have a natural log. We don't have e. Now, the natural log is already isolated here. So all we have to do is we're going to use e to undo the natural log. So here's the tricky part here. We're going to say e, and we're going to make the natural log of 5x the exponent. Same thing for the other side. We're going to have e, but this time we're going to make 4 to the exponent. So this is now an exponent, and this is now an exponent. So the property says that if we have e to the natural log of 5x, what we're left with is just 5x. So your calculator will calculate what e to the 4th power is. So we're just going to leave it for now. And then the last thing you got to do is just like any other algebraic expression. We need to divide by 5. So in your calculator, type in e to the 4th power divided by 5. You get 10.92. Okay, we have time for one more example. So we got natural log here, so we were going to use e to undo it. But remember how I talked about natural logs are still logarithms, so we can use our properties. Now we want to try to condense this side into one logarithm. Now, to get one logarithm, we've got a plus here. So we're going to use the product property. So we're going to have natural log of, and we're going to multiply these two. 2x times x, which is 2x squared. And that's equal to 3. Now we have the natural log isolated. We only have one. So to get rid of it, we're going to use e. So just like before, we're going to make both sides exponents. So we have e to the natural log of 2x squared is equal to e to the 3rd power. Now, on the left-hand side, using that property, all we have left is 2x squared. And that's equal to e to the 3rd power. Okay. Next thing we got to do, we got to divide both sides by 2. So the 2's go away here. And you can use your calculator to do e to the 3rd power divided by 2, and you get 10.043. But there's one more thing we got to do. We got to take the square root of both sides. And remember how we have to take care of our square roots. Whenever you take the square root, whatever comes out, you've got plus or minus of it. So we get plus or minus 3.169. So that means we have x is equal to positive 3.169 and x is equal to negative 3.169. But like we did yesterday, we need to make sure that our solutions are not extraneous. So if you look back originally up here, we got 2 spots for our x's. Obviously, the positive one's going to work because 2 times that positive number is still positive. When we plug it in here, it's still positive. So that's one of our answers. Now when we put in the negative one, already right there, it violates the rule that we can't take a log of a negative number. So this solution is extraneous. So remember, when you're solving using natural logarithms, e's and natural logs act like opposite operations and they cancel each other out.